All right, thank you to Per-Andre and Advancia for inviting me to talk to you. My talk's going to be a little bit different to what we've seen thus far. A little bit more philosophical and a little bit more cynical, I hope. I think I want to start by saying and reminding you that the opposite of variability is uniformity. And uniformity, as one of the previous speakers have said, is really what our objective as nutritionists is. We want to produce feed that meets our specification, hopefully with a consistent ingredient composition. We don't want to chop and change too much. This allows us to achieve adequate feed intakes. Remember, the birds suffer from neophobia. Anything that changes they don't like, so they stop eating it. So we want to keep our feeds consistent, and hopefully we can produce uniform carcasses and consistent product. So that's our objective as commercial nutritionists. As I've said, consistent feed stimulates feed intake because you avoid feed refusal. This improves performance, and it makes any predictions that we may wish to make a lot more accurate. So we at least know that we're going to achieve the feed intakes, the FCRs, and the target masses we set out to do. I think importantly that if you perform better as a broiler producer, you become more sustainable. And this isn't to talk about sustainability, but you need to remember that sustainability has different components to it. People tend to forget this. There's an environmental leg. We want to reduce our usage of land to grow soybean meal, for example. We want to reduce our pollution from nitrogen. These are the environmental components. There's a well-being component, which includes both human well-being and animal well-being. And somewhat cynically, some Australian workers have shown that most humans are concerned about their own well-being, and then they worry about the animals. Because Jamie Oliver and all the other celebrity chefs have told them if they eat organic chicken, they're going to be healthier. Okay? So they're worried about that. They're not worried about the chicken. And then, of course, all of those of us in business know that if we are not financially sustainable, we don't have a business. Okay. What tends to happen, cynically and aside, is that each of us worry about our own particular component of the sustainability debate. So you'll find the welfarists completely forget about the environment, and the environmentalists completely forget about the money, and us money people, we completely forget about everything else. So we need a bit of a balance here, but the good news is if you do your nutrition correctly, you actually impact on all three areas. From a variability point of view as a nutritionist, there are 4 major areas that are of concern. Probably the simplest and most important is measuring your moisture content in your diet and then doing something about it. Okay. Secondly, we need to look at protein, and I should have put digestible amino acid levels in there. And we've made really good strides with this in the last while, particularly with NIR systems. I think the aspect that is probably the most challenging is determining the dietary energy levels. And I don't know when any of you read Gonzalo Mateos's paper in Applied Poultry Research, was published towards the end of last year. And in there he said, you can't, I'm paraphrasing him, you can't believe it that it's 2018 and we still can't determine AME accurately. It's in his paper. It's really better written than I've just said. And then we need to be aware of mineral levels. And Bob has just told us about guys who add calcium to the soybean meal to make it flow better in the ships. I assume that's where it's in the ships and the silos. So these are things that we all need to be very much aware of. We talked about it briefly, ingredient form, handling, the degree of processing. All of these things impact on our variability. And the other speakers have done a very good job of explaining this already. I think that it's important that we realize that our requirements for our birds and our feed intakes vary dramatically between different production systems. And this is both at a flock and at an individual level. So an open-sided house in Zimbabwe with an earthen floor, you're not going to get the same kind of feed intakes that you're going to get in a controlled environment house in Poland. So these things we need to consider as nutritionists. But I think the point I'm trying to get here, and Bob alluded to this, is that the benefits of oversupplying nutrients is far outweighed by the penalties that are imposed by the undersupply. So we need to be very, very careful. Oversupply costs us money, but undersupply costs us a lot more. We see a lot of poor performance. At the APSS meeting in Sydney, there was a fantastic paper that made me think about things in a slightly different way. And unfortunately, the topic was the feeding of slow-growing broilers. And I immediately think these birds growing to 2.6 kilos in 56 days. And in fact, that's not what it was about at all. It was about slow-growing individuals in a normal flock of birds. And what they found is that slow-growing birds consume surplus amounts of essential amino acid, and fast-growing birds overconsume non-essential amino acids. So within one flock, you've got some birds that are eating an adequate amount of essential amino acids and so on. And it was quite interesting that they found that given the choice, when they gave the birds a choice of feed, slow-growing birds consumed diets rich in non-essential amino acids as opposed to essential amino acids. Who would have thought that that would have been possible? So we're feeding these flocks of mixed birds, and within that flock, the birds have got different characteristics. I think the most interesting thing in that paper was that they found that slow-growing birds were able to up-regulate gene expression for alanine catabolism. So they could actually identify slow-growing birds by measuring this gene expression. And at the same time, the uptake of the non-essential genes were down-regulated. So we think we're feeding a flock of birds, or we're feeding an average bird, but in every flock there are just such big differences that it makes the variability that we see in ingredients quite small. Okay, so what do we want to do as commercial nutritionists in the perfect world? In the perfect world, the NIR results that we achieve in our feed mills would be perfect. Okay? And we would be able to use a system like P&E to analyze each parcel of incoming ingredient. And by that, I mean every half a truckload or something, each parcel, because that's how big the variability is. We would be able to preserve the identity of those ingredients some way, and then possibly formulate our diets on a real-time basis on the fly. And I know that the idea of putting an NIR feeding into the way hoppers above feed mills is gaining traction. So we can formulate on a real-time basis now. And we would like to eliminate all weighing, mixing, and cross-contamination issues. And then, of course, we would like to feed average birds, which don't exist. So this is the perfect world. In reality, what happens is that an NIR is only as good as the calibration used to put it together. Okay? Most of us do not check enough incoming material at all. We just don't do it. I know companies that got NIRs that hardly use them. Wonder why, okay? We don't preserve the identity of these ingredients very well. We've got a silo that's got soybean meal in it. And when those trucks start coming in, it just goes into the silo. There's no other option. Where are you going to put it? So that's a problem. Then the famous one is that what we do is we're formulating using an average for our ingredients. Really, how dumb can we be? But that's the only way we can do it. There are limitations to formulation. And then we formulate assuming that all our parameters are both linear and additive. And we know very well that fat, for example, is not linear. If you use a little bit of fat, you have a huge extra caloric effect. If you use too much oil, you have a depression in energy. It's not linear, but we formulate on a linear basis. This is a real problem. Okay? Then what we do, we're really clever. We round our formulations so that they're easier to manage in the feed mill. Doesn't make a lot of sense. Most of us make weighing and mixing errors. You just don't need to run your mixer long enough and you've got a mixing error. Okay? We incur milling losses. I accept that a lot of that milling loss is moisture. But do we ever measure whether that dust that is going out of our mill is carbohydrate or starch? I bet you don't. I don't. I've never done it. Never thought of it. All right? Then most of my clever customers and clients use this famous thing called mixer meal. We just put 5% mixer meal. That's the feed that's come back or out of stock or out of spec. You know that stuff that accumulates in your feed mill? I see people looking at me. They don't know what mixer meal is. Returns to the feed mill. And then we put it into our feed. Really clever when you're trying to reduce your variability. And then, of course, some clown will always deliver the wrong feed to the wrong farm. It only happens in Africa, doesn't it? You know, we really do our best to mess it up, which has me worried sometimes. When you start looking at variability in feed, you start finding some things that you don't really like the look of. And the first is that ingredient variability accounts for somewhere between 20 and 25% of total product finished variability or finished product variability. This is increased by about 80 to 85% when you start worrying about things like weighing errors, the batch size, sampling and analytical errors, and so on. So it's not just about the incoming ingredients. I put there that formulation errors could and should be added, and I'm sure that Franco, you're going to deal with that more tomorrow. But we forget about the errors we make as nutritionists. I think that the important point is that we need to remember, though, that variability is not additive, it's multiplicative. It's not 2 plus 2 equals, it's not 3 plus 3 equals 6, it's 3 times 3 equals 9, okay? And very small changes in one parameter can make a large difference. Now, I've thought about this long and hard, and I thought, how can I illustrate this to you graphically? So I hope this works. So what we want is a high degree of uniformity. We need to consider our ingredients, our weighing errors, and our mixing and formulation, for example. When we have ingredient variability, and I've just put crude protein there, we reduce our degree of uniformity. If we have a macro scale weighing error, we reduce our uniformity. Can you see that this is all, this degree of uniformity is decreasing multiplicatively? So you can see that you can carry on adding these things on And so your degree of uniformity declines and decreases dramatically. So if you can eliminate mixing error, you can make a big difference to your uniformity. Or you can have accurate macro scales, or so on. So the opposite is also true. So yes, they're multiplicative. But if you can make small differences to the different aspects, you can make a huge difference to your overall variability in your diet. So it's a whole team effort that is required. In order for us to formulate diets accurately, we need an accurate description of the nutrients of the ingredients, and we need an idea of the variability we will encounter. And I think we've seen that very, very well in the previous talks today. I want to tell you from a slightly cynical point of view that long-term historical data, to me, is practically worthless. We have to have it to build up our calibrations for NIR. But I'm not interested in the 2018 crop report, because I'm actually mixing feed in 2019. I want to know what's happening now. History is meaningless to me. Okay, so I've got a problem with that. And the point is that we've seen today that both our crops and our analytical methods change. So if you're showing me that NRC from 1994, no disrespect, one has to wonder how they did the analysis in 1994 when we know how much everything else has improved. And I don't know whether this is not the same paper, but this is what Bob showed earlier, is that soybeans are changing. With time, the protein content of soybeans is dropping. And I'm not going to go through that. And interestingly enough, exactly the same thing is happening with corn. And that the crude protein content of corn is dropping, whereas the starch content is increasing. And it's not done intentionally, but remember that it's starch that is needed to make ethanol and corn syrup and all of these things. So the plant breeders are selecting for high yields of starch. The net result is that the crude protein is dropped. So what I'm trying to say in a roundabout way, if your data is 10 years old, it's probably wrong. And if you're using Ewing, which was published in 1932, I've got a sample copy in my drawer, on my bookshelf, it's going to be completely wrong. So you've got to keep up to date with these things, otherwise you're going to be wrong. So how do we deal with variability as commercial practitioners? Pierre-Andre gave the example of champagne with 70 different varieties of grape. And actually, I think that the truth is that the more ingredients used, the less variability is an issue. And I would agree completely that the number of ingredients that feed mills are using is reducing. Meat and bone meal, for example, has been banned in Europe and in my country. But the other thing, of course, is that we used to be able to use small parcels of ingredients because we had a small mill making small amounts of feed. Those small parcels of ingredients in a big mill are a nightmare. You haven't got a bin for them, you've got nowhere to put them, so you just don't buy them. So what's happened is mills have used less and less ingredients. Okay. However, if you want to use lesser known ingredients, they can be problematic because the data is not there. And I don't know how many of you get, somebody sends you, oh, we've got some macadamia nut residue. And they send you an analysis which has got crude protein, fat, and an energy value worked out on the Atwater factor for human beings. And Atwater, I would remind you, was published in 1906. So it's really up to date. The human nutritionists are right at the cutting edge of energy metabolism. All right. We do know that every time you weigh something, you make a weighing error. So the more ingredients you have, the more weighing errors you're likely to make. So that offsets the fact that you're using more ingredients. Okay? And as I've said, most mills, in my opinion, are using fewer ingredients, And these few ingredients need to be a source of absolute consistency. And the honest truth is, if we understand our grain and probably our soybean meal, in most circumstances, you will deal fairly adequately with your variability. The other thing you could do is you could use precision real-time analytics, and I say NIR, but remember the accuracy depends on the calibration, and you've got to have enough samples. So you need a large sample database because you have to consider those outliers. And that's why I say historic data does have value. It does have value for calibration. And then you need to be aware that the method that was used in drawing up the calibration is really important. And you've got to remember that no NIR output is going to be better than the input. In other words, no NIR output is ever going to be better than the data that was used in building the calibration. And this is some data that was shared by Pascal, and where he is, from Advancia, and it's really quite interesting because this is the AME of soybean meal, and you can see there's this many hundreds of thousands of samples, and there's a fairly sort of steady block there, but the real issue is on the x-axis we have the AME from the WPSA equation, and on the y-axis we have the AME from the P&E NIR system. And you can see here the relationship between the two is this blue dotted line. If the two values were the same, the relationship would be that orange line. So what it basically says, if you're using the WPSA equation, you're going to be underestimating the high value material and overestimating the low value material. So the importance of using, and remember that the P&E system is built up from real AME determination of feeding broilers. It's not an equation, it's real data. So you can see how if you use the wrong data in building your database, you can be misled by NIR. Just for interest. Paradoxically, of course, all the data that is produced by the NIR is difficult to use meaningfully. One of the previous questions was, what do we do with all this NIR data? And if it's historic, my advice to you is to ignore it. You know, worry about the stuff that's happening now. Okay? So what do most of us do? We still tend to use the mean. We don't make too many changes. Or we're pretty good at completely ignoring the data. And that has its own limitations. Again, this is the Advancia data, and it's exactly the same data set that Bob just showed you. And if you're in the average area, if you use an average value, you're okay. Not too bad. But what happens if you're not in the average area and you're actually below what you would think the line should be? I want to tell you those unexplained broiler performance problems you have, that's where it comes from. And then, of course, if you don't capture the upside, you lose money. So there's a huge amount of data in here. And then I said we're very good at ignoring things. And I was put up to doing this, and I think it's a really good idea. This is me fiddling around with a formulation. I use maize at 12% moisture, and then I increased the moisture content of the maize to 14%. And all I did is I substituted the one for the other. You can see exactly the same formulation, just substitute one for the other, and I recalculated the energy. So I've lost 0.2 of a megajoule, which is 50 kilocalories. All right? And in order to overcome that, I reformulated with the correct level of moisture, the normal manner, and you can see that both the soybean meal and the oil have gone up. But really what I wanted to show you is if my expected FCR was 1.6 with my formulation being correct, if I hadn't made the adjustment, the FCR would have gone out to 1.65. All right, remember, every 25 calories gives you 1 point of FCR, roughly. And you can see that my cost per kilogram of broiler has gone up by 3%. When I reformulate correctly and I bring my energy back to what it should be, that cost difference is more, but I'm not losing money. So ignore the moisture content of your corn at your peril. All right? It's going to cost you money in poor performance. I don't want to talk a lot about formulation issues. Just remember there's the risk of errors. All right? And yes, we do have models that can deal with variability within formulation systems, but they tend to be quite complex to use. You're laughing. And the trouble is, complexity leads to complication. And you know what human nature is? If it's complicated, we won't do it. So it's tend not to be a great solution. We need some practical solutions in order to deal with variability in formulation systems. And these systems need to be understandable and simple to use. And I hope, Franco, that tomorrow you're going to show us exactly that. Because you can have them too complicated. Okay, so what do we want to do as feed manufacturers to deal with variability? As I said, we want to preserve the identity of our disparate feed ingredients, and that's really difficult in a feed mill sometimes. We need to weigh and mix accurately, and it's unbelievable. I actually wanted to have a photograph. I've seen people weighing 100 grams of feed additive on an old-fashioned Avery balance scale. True story. So people do the most amazing things, and they wonder why they can't make feed. Simple idea would be to use more bins, but bins cost money, and often there's not space to put them into a feed mill. I would like to see rounding errors, minimum weighing quantities, and the use of mixer meal outlawed, but that's not going to happen because these things are still there. They're not going to go away. And I know that there's some arguments for using real-time feed formulation, and I know some companies are doing this. And what they're basically doing is measuring the ingredients coming into their weigh hoppers and formulating on the fly. The problem with it is it makes managing feed mill hell. So I just did a very simple example. I'm making 100 tons of layer meal and 300 tons of broiler grower. And I did a very simple thing. I changed the protein from my soybean meal from 47% to 46%. And I changed my sunflower meal protein from 37% to 38%. Now these are 1% differences. And this is perfectly understandable and what you would expect to happen. The trouble is that the formulation changed completely. You can see here I've suddenly gone to a maximum of sunflower meal, and here I was at my minimum. That's fine. It's not a big problem. We can do that and the birds will perform normally. But when you start looking at your inventory of raw materials, of ingredients, you'll see that you use a little bit less bran. But here's the real problem. You use less soybean meal, but you use 200% more sunflower meal than you thought you were going to use. So guess what happens? You run this formulation for 2 days and you run out of sunflower meal. Then what have you got to do? The famous substitution formulation that costs you a fortune. Okay, so you think that doing real-time formulation is a good idea? Think again. It makes managing your inventories a nightmare, and it makes your counting even more difficult. So I don't know whether this is a practical solution. I know the guys selling NIR machines want us to do all of this because they sell these inline NIRs and they work really well. But I don't know whether you can use that information sensibly. Weighing errors are probably our single major source of variability. And firstly, we want to eliminate them by making sure that the formulations are implemented correctly. And I've been in this business a few years, and I can't tell you how many times I've seen formulations that haven't been implemented correctly. And somehow, when it's automatic and it goes from the formulation system to the process controller, everybody assumes it's correct. It doesn't work that way. You've got to check these things. Somebody's got to check them manually. Batching software can mix these things up and make mistakes. Size and weights on scales are very, very important, and people tend to forget that. And remember that there's in-flight weight of materials. Good batching software takes consideration of this, but poor systems don't, so you can have variability there. And you certainly have issues with ingredient size and particle size and density. Limestone's a classic example. Nearly every feed mill I ever visit, the calcium level is higher than it should be, because feed mills do not weigh limestone very well because it's so dense and it flows so fast. Okay? As I've said to you, the more ingredients, the greater the error. But there's one positive, and that is the larger the batch size, relatively speaking, the smaller the weighing error is. And as feed mills get bigger and bigger, our batch sizes are getting bigger and bigger. So actually, by default, we're weighing more and more accurately. I'm still amazed that there are companies who make half-ton mixers and sell them, because you can just imagine how big the weighing error is on a half-ton mixer compared to a 5-ton mixer. It's huge. And then, as I said to you, we do all this fancy work and managing our variability of our feed, and guess what we go and do? We go and feed chickens. And they're as variable, they're more variable than the soybean meal. And lots of people will tell you that the very low feed intakes, particularly of small broiler chicks, is why variability of the feed is so important. I want to challenge anybody here to go and find any research on this, because I've tried. I really tried. And there's very little evidence of it. I did find one paper that was published by McCoy in 1994. And what they did is they used a common diet, and they simulated variability by poor mixing, intermediate mixing, and adequate mixing. And when they fed them to broilers, they found there was an improvement from poor to intermediate, but there was no improvement from intermediate to adequate. Okay? And then Benker, and I unfortunately don't have a date on this particular reference, believes that CVs of up to 20% on feed may be adequate for broiler growth. Wow. So we're worrying about variability, and the chickens don't really mind. Then I came across this interesting MSc while I was looking at this work. And what they were actually doing was looking at meat and bone meal. And they fed a 57% material and a 50% material. And when they formulated these diets, taking that into consideration, you can see that they've got the same FCR and the same FCR and the same body weight. This is just at different ages. They then did a very interesting thing, and they took this 50% material and they mixed it with the 57 on an alternating basis. And that's what the A stands for. And you can see that it made no real difference to the FCR at all. Now they're mixing 50 and 57% material. They're trying to induce variability, and they couldn't do it. And then when they formulated correctly with 50% material, what they did, they formulated with 57, and they just substituted 50% material. And you can see here we've got, not even there have we got a significant, slight difference in FCR, 2 points. So they were trying to mess these birds up. and they didn't really succeed. So what I want to say to you is this broiler that we have is amazing. It really is amazing. And sometimes I think we overthink these things. I really do. Okay. When one goes and looks at individual laying hens, and I've just been feeding some individual birds, 3 different energy levels, 4 different lysine levels, and when you go and look at the average feed intake was 111 grams, and nobody's going to say that that's good or bad, that's pretty average. But the bird that ate the least in the flock ate 81 grams, and the bird that ate the most ate 145 grams. These normal laying highline browns. Can you believe that the feed intake would be that different? Interestingly enough, there were 2 birds that didn't lay, and they only ate 63 grams a day. So they didn't eat at all. They were just coasting along, staying alive. So, yeah, you think variability is important. I don't know whether the chicken thinks it's that important. So I want to end off by saying that we don't live in a perfect world, but it's essential that we measure in order to manage. And NIR and its calibration is a case in point. You really have got a system that is effective. And yes, we appreciate that the system is not perfect. But remember that whatever we apply only has to be better than what we were doing before. And NIR might not be perfect, but it is way, way, way better than the old wet chemistry labs that I grew up with when I was a boy nutritionist. It's hugely better, all right? The big thing about it is it's going to allow us, or it should allow us, to move away from the use of averages and historic data. And it should allow us to make those small changes in variability that have big outcomes. Remember, variability is multiplicative. So I'm very positive about the direction we're moving in as an industry. And I want to say NIR calibrations are a classic example of machine learning. The more data you feed them, the smarter they get and the better they get. And companies that are investing huge amount of money into these systems are to be congratulated, because we can all participate in this improvement. So systems such as the Advancia system allow us to avoid materials or suppliers that are variable or unreliable. They allow us to manage ingredients in such a way as to minimize variability, and hopefully they will allow us to formulate our diets more accurately. And as good as they are, they do not make up for poor feed manufacture. And they do not play any role in flock variability. And I want to end off by, it looks like it's a quote, but it's me. As always, everything we need to do, we need to strike a balance between what is possible and what is pragmatic or practical. Systems mustn't be too complicated, but they mustn't also not be too simple. Thank you very much.